How you doing today? Good?
Yep,
Great.
except for computers.
Yeah. All right. Looks like we are live. All right. Hello, everybody. I'm Logan Arliss here at Illinois Aviation Academy, coming to you for another Webinar Wednesday event. Really excited about this one. I'm joined here with Michael Coates, Pipistrel Aircraft Dealer of the Year 2012 as well as 2017, as well as the EAA August Raspet Award winner in 2012. Michael, how are you doing today, sir?
I'm doing great, thank you.
First off, I just want to say thank you so much for joining us and sharing with us about the wonderful company that is Pipistrel.
Yes, it's a pleasure to be here, and it's great to be representing such a dynamic company as Pipistrel in the US market.
Absolutely, it sure is. And Pipistrel is headquartered in Slovenia, and they
Yep.
started in 1980s. And in the early 2000s, they really took an initiative on developing a clean energy solution to the aviation industry. I would kind of call them the Tesla of aviation, if you will. And it's got to be pretty cool and rewarding to work with such an innovative and cutting edge manufacturer.
Oh, it is. It's great. They're really into green technologies and green aviation, green manufacturing. So it was obvious for them to go through to electric aircraft, and they hold the pleasures of being the first two-seat electric aircraft to fly in the world, the first four-seat electric aircraft, and we've won multiple NASA Challenge series, which has been fantastic.
Absolutely. So I'd like to start off just ask if you could provide us with a brief history of Pipistrel and their transition to becoming so focused on clean energy solutions within the aviation industry.
Okay, well, they started back with electric about 2004. That was their first attempt, and with the graphic you've got up on the screen there, they were using the Taurus Electro. Back then, it was a very different aircraft to what we're selling now, in that it has lead acid batteries and things like this. It was more a proof of concept. Lithium batteries then came onto the scene, which were significantly lighter and packed more energy density into the same size package. So they converted to lithium batteries and introduced the first aircraft to the public in 2007. And these were sold pretty well. Probably about 40 of these original aircraft were sold. They've since been upgraded from generation 1 to generation 2, and 2.5 is what we're selling now.
Absolutely wonderful. So what would a future with all electric aircraft look like, and why is Pipistrel, investing so heavily on being the front runner of electric aircraft?
Green technologies, it's sort of like not just a fad, it's a way of life for the owners of Pipistrel. All of their manufacturing, so building the aircraft, is all done without any sort of greenhouse effect output from the factory. They rely on thermal heating and cooling. They run solar for all their generation. So it was obvious to them to go to electric aircraft. We've got, an infrastructure almost in place to be able to fly these aircraft for free. And that is, we've got every aircraft's in a big hangar. A big hangar means you can fit a lot of solar panels on the roof. You can put batteries inside, deep cycle batteries to recharge the aircraft. So you can go out flying. While you're out flying and discharging the aircraft, the solar panels are recharging batteries in your hangar. So when you come back, you can do a fast charge and go out flying again. The biggest limitation at the moment for electric aircraft is, of course, the duration, how long they can fly for. That's the biggest issue we have.
Yep. So that was exactly my next question. So we're seeing, cars, trains, everything operating fully electric. So the biggest thing you would say now is the efficiency then of the batteries, which is keeping the aircraft electric.
Yeah.
Market.
Depending on who you speak to, the motors are not going to get much better because they're running at about 97% efficiency. Battery technology seems to be, and I'm just parrot fashion repeating what I'm told. Battery technology is increasing at about 6% a year. The batteries used for electric aircraft are unique. They're not, Tesla batteries. They're nothing like you can buy anywhere else. They're a unique battery. And the only similar groups of industries using batteries the same way we use an electric aircraft is probably the cordless power drills and drones. They're the only two technologies that are using similar use for the battery power supply. Because with an aircraft, you put on full throttle to take off, you're maintaining full throttle for probably a minute, and then you reduce it back to about 80% and fly around. Whereas if you've got a car like a Tesla, if you put your foot flat to the floor, you've got to take it off within probably 2 or 3 seconds. Otherwise, you're 3 times the speed limit and going to hit something. So the chemicals, the way they work, the way they discharge is completely different in aviation to just about every other battery use. And we just don't get the funding being spent on research and development. So the battery technology for aircraft is progressing slowly when you compare it to things like mobile phones, which are made daily in their millions. They've got the money to invest in this technology to make your talk time, 24 hours instead of currently 4 hours.
Right. Absolutely. Yeah, that's very interesting. So Pipistrel was the first manufacturer to receive a certified aircraft or to get a type certificate.
Yep.
That was on the Velis Electro. So
yep.
How challenging was it to receive a certificate when you're bringing such a unusual and new idea to
It is difficult. The Velis Electro certification overall took about 4 years, but it's not just certifying the aircraft, because we used the certified airframe from another model called the Virus 121, which is again a certified gasoline equivalent. So this was re-engineered for an electric motor, and the certification involves a lot more than just testing the motor. We had to do things like puncture tests on batteries. So, you drive a screwdriver, it's in the side of it, obviously remotely in case there's an explosion, but they needed to validate that impacts like that wouldn't create a runaway fire. They intentionally overloaded cells, 1 cell and 5 cells and 10 cells, overload them till they explode to make sure that the rest of the battery doesn't explode with it. So there's a lot involved, and it's a new area of aviation and battery technologies that we're testing.
It sure is, yeah. And Pipistrel is leading the race in that industry for sure. So could you talk to us a little bit about Pipistrel's electric aircraft fleet that are currently available to the market, and what makes these aircraft such good training planes?
Okay, well, we make basically 3 electric aircraft, and that's the Taurus Electro, which is a side-by-side self-launch sailplane. So the best way to describe that is it's really a glider, side-by-side seating, so it's good for instruction. It's designed to take off. You'll climb to, say, 2,000 feet, turn it off, and then go soaring at about 40-to-1 glide ratio. So that's the original model we developed in 2007, because that was the best way to get electric aircraft flying, because we didn't have the duration at that time. We then teamed up with Siemens for an aircraft that was a development aircraft called the What's Up. And that aircraft used Siemens motor, our battery technology and controller, and it did a lot of testing and flying around. The problem was, however, that the Siemens motor on its own was worth more than the entire rest of the aircraft. So there was no future pathway to cooperate with Siemens when their products were so expensive, because it would have more than doubled the cost just to have a Siemens engine. So we teamed up with another smart company from Slovenia, a company called MRAX that had been making electric motors for some time. We put our own design knowledge into it, had them engineer something different than was off the shelf, and that became the very first Alpha Electro. That's been selling now for about probably 7 years, 8 years. And the next generation of that is the latest aircraft, which is the Velis, and that's the certified model. The two main differences between the Alpha Electro, which is still available, and the Velis is that one has air-cooled batteries and the other has water-cooled batteries.
Wow.
The water-cooled batteries offer better performance in very, very hot environments. So say, we've got 4 aircraft in Fresno in the California Valley. If they're out flying on 100 and something degree day, they come back, they actually have to use little air conditioners to cool the batteries down so they can be charged. Otherwise, the batteries remain too hot. With the water-cooled batteries, you don't have that same problem.
Wow.
Water cooling seems to drop between 20 and 30 degrees Celsius, the temperatures against the air-cooled batteries, and that makes a big difference when it comes to recharging.
Absolutely. So what can you tell us a little bit about the performance of these aircraft? So the range, speeds, endurance, those type of things.
Everything is identical to its gasoline-powered equivalent airframe. So the Alpha Trainer, which is a Rotax 80 horsepower, is identical to the Alpha Electro aircraft in its performance, its climb rate. Everything is identical except for 2 things, and that's cruise and endurance. You can cruise at the same speed, but you're sort of wasting a lot of electric power reserves by doing that. So the best way is to cruise a bit slower and you get more endurance. But everything else is the same. We're currently operating on a advertised endurance cycle of around 50 minutes of circuit training, and we still maintain a mandatory 30 minutes reserve. And that's the same with both aircraft. The Velis, which is a water-cooled, has 55 minutes plus 30 minutes.
Interesting. So how long does a recharge take on the batteries?
Depends on the temperatures. Basically, if everything's ideal, you'll reach, and you've got enough power, of course, you'll recharge in about 40 minutes. And that'll give you, enough to go for another 50-minute flight. If it's really, really hot temperatures, then the charging actually slows down so it doesn't overheat all the batteries and cause damage. And if it's a really, really cold environment, say, Alaska in winter, it'll take a lot longer because, first of all, it'll warm the batteries up to get them to a suitable temperature, then it will charge them. So that can take some time. But if you've been out flying already, the batteries have got warmth in them, then they'll charge up quickly. But a lot depends on how much power you've got. So if you're just coming out of a 110 wall plug in a house, the recharge time is going to be probably well over 12 hours. Whereas if you've got 3-phase power, you can plug it in and go very quickly.
Interesting.
These aircraft are still only designed, or our recommended use, I should say, for them is flight training, because they don't have the endurance to go cross country. There's not a charging network in place to go cross country at the moment. So you can't fly to another airport and land and then get back again because there's no recharging facility at that second airport. So they're ideal for going around in circuit. And the noise footprint of the electric aircraft is incredible compared to gasoline. Basically, we've failed all of our noise testing. And the stupidity of saying that it's failed is that we haven't been able to record the electric aircraft above ambient noise at airports. So we can't say, okay, this aircraft is producing, 80 decibels or something as an example of noise, because it's not above the background level of noise. You've got the birds and the wind and the cars, and the electric aircraft is below those noise levels. Even at full power takeoff, you can only hear just a smidgen of noise as the propeller comes to 90 degrees to you. Either side of 90 degrees, you can't hear anything. And if the aircraft is overhead at 500 feet, you can't even hear it.
Wow.
So for areas that have got a lot of issues with noise around training airports, the electric aircraft is really the way to go for the future, because people will have to stop complaining, because they're always complaining about noise, and now they can't.
Yep. They'll have to find something else to complain about.
It'll cast a shadow on their washing or something.
While they're sunbathing, yeah.
Yeah.
So how about hot swapping batteries? So would it be possible if you had an extra, battery cell, or I'm not sure how many batteries are actually in each aircraft, but could you hot swap them to, land hot swap, increase your range?
You could, but it's not practical for a couple of reasons. When we originally designed the system, it was going to have 6 batteries. So each battery would be the size of sort of like a briefcase, roughly. And you'd be able to pull them out and put in another 6 and go. But Pipistrel quickly worked out that the batteries that were being swapped out were being, I won't use the word mishandled, but there's chance of damage if they're dropped or knocked against something or put on the ground the wrong way. So they eventually decided to go with 2 battery packs. So they put 3 batteries into 1 battery pack. They saved a heap of weight because they're in the 1 enclosure. But the only problem for that was that they got pretty heavy. So each battery pack is now about 55 kilos, which is about 120 pounds.
Yep.
So you can change them out, but it's not really practical, because by the time you do all of that, get a cart and get the cart to the right height, pull the battery out, find a new one, put it in, you're coming up to about 40, 45 minutes, which is the same time as doing a recharge. So Pipistrel have decided to go the fixed battery way of operating the aircraft, and they just continually keep working on the recharging to get the recharging quicker and quicker.
Interesting. We had one question come in from a viewer inquiring about the maintenance that goes into one of these airplanes. So compared to maybe like a traditional 172 training aircraft.
Yep. The maintenance of electric aircraft is a lot less than conventional aircraft. And basically anything that's electric, like a train, a locomotive train, most of those are diesel electric. So the diesel is just a generator and everything else is electric. The maintenance is much lower. The motors should be about a 2,000 hour TBO. That's what they're advertising. In the early days, there were a couple of motor failures from bearings. Pipistrel worked on that, and they fixed that problem. But it's like any new industry in its infancy. You're going to make 3 steps forward. You'll probably take 1 back at a particular time and then go forward again. So the motors are a 2,000 hour TBO. There's nothing that a user can replace in there. The batteries are completely sealed. They're high voltages. So there's a possibility of someone getting, injured or dying from playing with the batteries. So they're sealed so it doesn't allow people access to get in there and tinker with a soldering iron. And the rest of your maintenance is really only airframe. So with 100 hour, you'll sort of look at the motor, the batteries you're looking at every day as part of the recharge cycle, and they give you warnings or error messages if they ever happen. And the rest of your 100 hourly is going to be checking the brakes, lubricating the parts that move in the ailerons and the elevator, the pins that are there, and it's pretty straightforward. So if a typical LSA was taking 4 hours to do a 100 hour inspection, the same aircraft electric would probably take about an hour.
Wow. Awesome. So
that reduces your costs of ownership.
Oh, yeah.
But having said that, electric aircraft are still more expensive. So if we do a direct comparison, an alpha trainer, which is gasoline, versus an alpha electro, the alpha trainer is probably going to be marginally cheaper to operate in a flying school type of environment than the electro over the same period of 2,000 hours.
Wow. So why is the electric aircraft more expensive?
Battery replacement. At the moment, the batteries, we're saying they're good for about 500 hours.
Yep.
Once they get to 500 hours, they're still good batteries, but you're slowly reducing your range. Correct. So it's like a mobile phone. You get it and it's brand new. It lasts you a whole day. And after a couple of years, you've got to toss it out because the battery's only lasting 4 hours. Yep. So it's the same with electric aircraft. The batteries get used up. We take them out and recycle them so they can be used for other industries like electric storage in a home. So they're still more than good enough for that type of environment. But, aviation needs really good, top performing batteries with the most endurance you can get. And we're saying 80% of the duration of the battery is its limitation.
Makes sense. So being a dealer, what are you seeing in terms of electric aircraft sales and market's willingness to transition into electric aircraft?
A lot of inquiry for a lot of electric aircraft. I'm very upfront with the customers and suggest to some of them that it's not what they should be buying, because they want to go from airport to airport to airport, and you can't leapfrog with electric yet. So we say, for you, you're going to be best with a gasoline because it'll fulfill your role. But if it's a flying school just going around the area, they've got problems with noise, like Santa Monica, everyone's trying to close that because of noise. Then electric aircraft in that situation is more than ideal. Yep. In some areas, we've got concentrations of electric aircraft, so you can actually do cross-country flying there because there's a network already of charging stations, so you can go from spot to spot to spot and keep flying. So yeah, the biggest problem in the US market for electric aircraft at the moment is one word in the FAA legislation of what makes up an LSA aircraft. So an LSA aircraft in every other place in the world is an aircraft that can use basically any propulsion system. But in the USA, we've got one word that says reciprocating engine. And that was thrown in by the lawyers right at the end because they heard that people were going to start putting rockets and turbines and things like that in LSA aircraft, which are meant to be simple aircraft to operate. So what we've done now is we've petitioned the FAA. They've agreed that that was a mistake to have that word reciprocating in the regulations. So they've already changed it, and it's just going through the legislation changes and sign off by Congress at this time. So as soon as that happens, electric aircraft will be able to be officially used for training in the US. So they'll instantly become a lot more popular. Yeah. At the moment, they're operating in the experimental category with letters of deviation. So a flying school may purchase one and go to the FAA and say, look, this is a certified plane. It's operating everywhere else in the world as an LSA. Can I get a dispensation to operate it in our flying school, agreeing to follow the maintenance for the LSA model? And for more reports, the FAA sign them off and off they go.
Awesome. Well, that's good news moving forward. Now, this is an aircraft made by Pipistrel called the Surveyor, and it is really interesting, something I've never seen before, where it can be either fixed for an unmanned aircraft system or a piloted aircraft. So could you tell us just briefly a little bit about this airplane and what it was made for and what it's going to be doing?
Well, what you've got there is actually a picture of a Virus SW, which is a very popular airframe that's in the US already. but we utilize the same molds to produce a model called the Surveyor. So the Surveyor is optionally piloted aircraft, so it can have pilots operating it, which is required in some markets, or it can be completely UAV. We've got a number of these aircraft operational with the US Air Force in different parts of the world. We've got some in other countries that are used for surveillance in the military market. Some are used for telephone interceptions, and some are used for aerial mapping and power line surveys. So, it's just utilising a very inexpensive, by comparison to other aircraft or helicopters, it's utilising that airframe, which is really, really efficient for doing a surveillance role, and it's proving to be really, really well accepted. For example, Global Hawk is tens of millions of dollars. This thing can almost do the same type of sortie, and you're paying, $200,000 for the airframe plus all of the parts that go into it. So you've got a $3 million product instead of something that's tens of millions. Endurance-wise, we're flying these for over 40 hours in a UAV environment.
Wow, that's amazing.
So they've got the ability to get up there and just loiter. They're running Rotax engines. They're pretty fast if they need to be. So the example you've got there will cruise at almost 150 knots.
Wow.
So you can get from A to B pretty quick and then just loiter over your area of interest, whether it's military or a bushfire or, a forest fire. And then you can beam in real time, good footage, LiDAR information back to headquarters.
Wow, so cool. So aside from electric, Pipistrel has also pursued another fuel source, which is hydrogen, and they were partners on the High 4 project, which was the world's first 4-seater passenger aircraft powered by hydrogen.
Yep.
So with hydrogen being such a cleaner source of fuel, why aren't we seeing more hydrogen-fueled planes in this day and age?
I can't answer that, to be honest. I'd like to see them at every airport, but it's a matter of the cost. Producing hydrogen can be expensive if you're in the wrong area. Again, I'm not the expert in this, but I'm telling, what people tell me. If you've got, say, a windmill that's used for electric generation and it's somewhere near an ocean, then of a night time, you've got everything you need for producing hydrogen, which is salt water and electricity. So in those type of locations, you can basically produce your hydrogen for next to nothing, because the windmills are still turning overnight, but we're not using that much power, and we're not going to run out of salt water in an ocean. So in those environments, yes, it's a very good option. But if you're in the middle of nowhere and have to make it the old-fashioned way, then it's quite expensive to do. But it seems to be, I personally believe we're going to go for a hybrid type of aircraft before we end up going fully electric, because electric is limited by the battery capacity. With the fuel cells, they're just becoming basically your generator that's supplying power to recharge the batteries and power the aircraft. So I think we're going to see, these hydrogen fuel cell type aircraft come in well before battery aircraft come in that do 19, 20-seater aircraft. They're going to be fuel cell before they're fully battery.
Absolutely. So Pipistrel has announced the plans to develop a 20-seat hydrogen-fueled aircraft. It was called the Mini Liner.
Yep.
Could you tell us a little bit more about this aircraft and what market it will fill?
It's basically just for short haul. So just, the 500-mile trips between a capital area and a regional centre. They'll be hydrogen, so they'll be refueled very, very quickly at their destination, and back they go again. So it'll just replace things like the Navajo Chieftains and upwards, up to that 20-seat sort of aircraft market. Maintenance should be much better on these. They're multi-redundant, so they're carrying not only hydrogen fuel cells, but two different types of battery propulsion. And if everything sort of fails, they're still good gliders, even though we don't expect everything to fail in a commercial environment. You've got to plan for the worst case scenario. So if one battery system dies, the other one will take over. They'll run on two engines instead of four. It's exciting times, and this is what we'll see, in my opinion, well before we see battery aircraft that can do 2 or 3 hours on their own.
Absolutely, yeah, that thing looks real cool, futuristic.
Yeah, well, there's a lot of designs. Just about everyone's got a VTOL design out there. I was reading something the other day that said there were 300 active builders of VTOLs and different conceptual aircraft. It seems everyone that has an opinion is in that market now.
Yep. Sure looks cool though. So another airplane that Pipistrel manufactures is called the Panthera, which is dubbed the Flying Ferrari. I mean, this thing just looks sleek, looks fast. Could you tell us more about this aircraft and what its future plans are?
Yeah, it's available now. There's about 3 in the US with another 8 or 9 currently on order. Most of those will be delivered before the end of this year. We'll have the Panthera at Oshkosh this year for the first time. The Panthera is building on the economics of the previous models, which is to go as fast as possible with the least amount of fuel. This aircraft should have come out, in my opinion, about 2013, but Pipistrel had some very big decisions to make at the time they were going to release the Panthera, and that is we got an order of 200 aircraft for the Indian Army, and we had, which was the largest single, light aircraft order ever. We also got a lot of orders for our military version. So Pipistrel, unfortunately, put the Panthera to one side so they could satisfy all of this extra income and ability to the market of their products. And then they came back to the Panthera a couple of years ago. It's in the process of getting certified at the moment. The ones that are flying are currently experimental, but it'll be certified probably next year. And that'll be a reciprocal agreement between EASA and the FAA.
That's awesome. So that's running, that's got a Lycoming, I think it's a 0540 in there.
Yep.
Are there any future plans to turn this into a hybrid hydrogen or electric aircraft?
Yes. I can't tell you too much, but yes, the goal is hydrogen or fuel cell electric and a gasoline electric. So, for example, we'll put a Rotax 915 in there, which is a certified aircraft engine, turbocharged. It'll basically just operate as a generator and provide power for batteries. Hydrogen fuel cell is also in the future, as is complete electric, but we don't expect to be able to sell any complete electric until there's a huge breakthrough in electric storage. Because again, you're back to batteries.
Absolutely. So such a cool airplane.
Yeah, there's a project called the Mahatma project. It stands for something I can't remember now, MEHAPA or something. And they've got quite a bit of information on what they're doing with the hydrogen and also the gasoline hybrid aircraft. And they're very close to flying. Maybe they've flown already, I don't know.
Awesome. So Pipistrel has really pioneered the advancement of clean energy in aviation, dealing both electric and hydrogen. So you already mentioned, really, you see a kind of a hybrid. The future is moving. Near future will be some type of hybrid, hydrogen and electric. Any idea on how long until we see, really a breakthrough and a trend going that direction?
It's already happened. What's dragging the chain at the moment is battery electric, because we just, an aircraft has to be light. We can't carry tons and tons of batteries. So the the best way to do it from there is gasoline electric. So you're using already an aircraft certified engine producing power to recharge batteries and run electric motors. Now, is that a big step forward? Yes, but no, because you're still polluting the environment by the gasoline engine, even though it's a lot less than a big engine and a lot less noise. It's still a pollutant. So I think hydrogen will be the big way forward. And there could be hydrogen aircraft available for sale as early as next year.
Wow. Well, interesting.
As you see from the High 4 project, we've been flying hydrogen electric for several years now. And those test beds gaining a lot of information and proving that direction, I believe, is the right way to go.
Absolutely. Man, such interesting stuff. I can't wait to look forward to see what Pipistrel has in store and the future plans of that company. And thank you so much for your time tonight. We thoroughly enjoyed your knowledge, your expertise, and sharing all that information with us here at Illinois Aviation Academy.
You know, Pipistrel have a slogan, or one of many slogans, but it's one of their slogans that I really agree with is, you've seen our past, so just imagine our future. So, you know, you've seen what this small company in Europe, part of former Yugoslavia, you've seen what they've produced in the past with all these new aircraft out there. So the future is really just up full of imagination projects that you and I have not even thought about. These young engineers working at Pipistrel have got some ideas which could possibly change the future of transport.
Wow.
We're not quite at time travel yet, but we're working on it probably.
That's amazing. I mean, that's such a cutting edge manufacturer, and you know, we're excited to see where Pipistrel goes.
Yeah, and me too. I've been with them for 22 years, and truly to see what's happened in that time. When I first joined them, we were working in a garage. So they had a garage under somebody's house in Slovenia, in a little village, and to put the wings on the plane to test the wing fitting, you'd have to go outside and stop the traffic. And they put the wings on, then take the wings off, the traffic could go again. And to go from that type of environment to what they've got now, which are world-class manufacturing facilities, is just an amazing achievement. It really is. And I'm so proud to be part of that organisation and company and to be there and witness its development.
Absolutely. Well, thanks again so much for your time. We thoroughly enjoyed it and hope you have a fantastic rest of your evening.
And I will do, and I invite everyone to come and visit Pipistrel at Oshkosh. Hopefully a lot of your people will get there. We're just inside the main gate on the right-hand side opposite Cessna, or Textron, or whatever they call themselves now. So, if anyone wants to come by, kick the tyres, we'll have electric aircraft, we'll have the Panthera and some of our conventional models there as well. So everyone's welcome.
That's awesome. We will we'll see you there because we got a passenger van that's going to be bussing a bunch of us up there. So we'll make sure to make it a stop.
You'll be the rowdy lot that come in singing songs and half drunk, will you?
That's right. All right, Mike, thanks again.
A pleasure.
Have a nice night.
Thank you. Thank you.